Hi everybody, Grandad here. And what am I up to today? Well, today I'm going to do a little bit more chemistry with you. But before we start, I just want to mention that I'm having a lot of trouble with my videos. And I would just want to apologise if some of the videos that I've put up lately have cut off before the end. It's because I'm having technical problems with the cameras and things, and in fact today's video I'm actually recording it with two cameras because I've had some problems with one of my phone, and it hasn't been uploading the videos properly, so I'm actually filming this on two cameras to make sure I try and get it. But today we're going to do a little bit of chemistry. Now this chemistry today is rather interesting because it's actually to do with gases. Now the gas we're going to produce is a rather smelly gas called hydrogen sulphide. Now it's a very dangerous gas, and in the factories where they deal with it, it's really is a life and death hazard. They have to make sure that they don't breathe any of this gas in. Now you may have heard of it, but they usually refer to it as bad egg gas because it actually smells like bad eggs when you smell it. But the strange thing about it is, in low concentrations it smells like the bad eggs, but when the concentrations get a bit higher, it actually blocks your sense of smell, and you can't smell it. So you think the gas has gone away, but in actual fact it hasn't gone away, it's still there, but you just can't smell it. And when the concentrations get really high, it can cause death within minutes and unconsciousness. So it really is a very dangerous gas. Now I'm surprised that this gas was actually mentioned in this chemistry set that I got from the I bought that chemistry set, and it was for children, and they actually show a process of making this hydrogen sulphide gas, and it says on here bad egg gas. But the problem with this is that if you look at my book here, if you can see the page that it's on, I don't know how well you can be able to see that, but the actual page has been destroyed by acid, and I can't read the exact information that was on that page to tell you how to produce the gas from the chemicals that were supplied with the chemistry set. So I'm not sure what they are. The actual writing is missing, so I can't see what it is. But I've discovered by looking at the internet there's another way of making this gas, so I thought I'd do that, and it involves using sulphur powder, which you can get from any grocery store. It's ordinary for stuff you put on your gardens. It's a fertilizer, and aluminium powder. Now you remember I got some aluminium powder from a Etch-a-Sketch? Well, this is one of the reasons I needed it. Now unfortunately I've already done this video twice, and I've used up a lot of my aluminium powder, so I'm not going to make a big batch today because I don't want to use up any more than I've got. But I wanted to show you the process. But the mixture, I'll just put my book out of the way for a moment because I'm not using that at the moment. The mixture is 2 parts of sulphur to 1 part of aluminium powder. Now as I say, this isn't the method that was shown in the book I've got, but it was a method used for producing the same gas from a YouTube user. I think it was from the backyard scientist. He's very good at doing different things, and I picked up this idea of how to make this gas from his channel. Now somewhere here I've got a spoon, and I'll just spoon out the quantity I'm going to use today, which is a level spoonful of the sulphur powder. Put that into there, and a level spoonful of the aluminium powder, or pretty much. That's a little bit more than that. Now I'm putting it into this little box because I want to mix it well. So I've got this little plastic box here. Now if I shake it up in there, this aluminium powder is really fine, and it coats everything. And as you can see, that little plastic box is completely covered with aluminium powder, and it's very messy, which is really why I need to have my goggles on and my gloves. I've already got some on my hands, but this aluminium powder is so fine, it really is messy. Now, the next thing you have to do with it is to set fire to it. Now, it's a little bit windy today, which is a bit of a nuisance, but I'm hoping the wind will die down enough that I can set fire to this for you and show you how it goes. And of course at this very moment there's a lot of wind, so I'm hoping it'll just die down sufficient that I can set this powder off. Now I'll undo the lid now, and as I say, it's coated this little container of mine. It's made it easier to shake it up and mix it, but it really is messy stuff and it gets all over everywhere. Now I'll just put that onto the burning surface there, and I'll cover it, and now I'm going to set fire to it. Now it's a little bit smelly and a little bit smoky, so I'm hoping it's going to work without too much wind. Well, the wind is actually blowing right towards me, so I'm going to move over here. This really is a messy process, dealing with this. It smells like matches. This isn't the actual gas that I'm trying to produce. This is the gas that's produced from the burning of these two chemicals. So it's a sort of a thermite reaction. It goes on burning for quite some time. Now the wind's getting up again. I was hoping that wouldn't happen, but it has happened, so there we are. Now when that's gone out, which it looks as if it's taken a long time to go out, I don't think there's any more to burn. Let me just try with my gas burner here. I think we've got it all out now. Now, I have actually got some that I've actually got in another container. If I'll just wait a minute while I get it. Sorry about that. This is what happens to me. I'm not always very well prepared and I can't find it. But anyway, we'll go on and hope that that's cooled enough for me to go on to the next process. Now I've got here some little a little phial with just ordinary distilled water in it. And I'll try and scoop up a little bit of this hydrogen sulphide which I just made, and I'll pop it into the water. I'm hoping it's not too hot. But believe me, it really is a smelly compound. Now I'm putting that into there, and I'm hoping, yes, it's starting to bubble already. Now as you see, the water is quite clear at the moment, but as it goes on, it'll hopefully dissolve and mix. Now just because it's so windy, I don't want this to blow away, so I'll just put that on top of there. Stop it blowing away till I can put it into my little container, which I can't find, which is a bit of a nuisance. I thought I'd got everything prepared, but I haven't. Now it's rather interesting that in the book, which I've got here, it tells you 2 more experiments that you can do using this liquid. Now there's quite a few bubbles coming off it now. So I'm hoping that I'm actually producing some of the gas which I'm talking about. Now I'll just try smelling it a little bit. It's supposed to be very strong, and I'll see whether it does smell. Yeah, there's definitely egg smell coming out of that jar. It's not terribly strong at the moment, but as I say, it's a strange gas. Even if I smelt it really well, they say that after a while of you smelling it, the smell goes away and you can't smell it anymore, although it's still there. So I'm not going to smell it too much because I don't want my smell buds to go away. But the next thing that it tells you to do in the experiment here is to use some of this solution, and it says add a little hydrogen sulphide, which we're producing inside this little thing here, to a dilute copper sulphate. Now in this little file here you can see I've got blue copper sulphate in this little file here. Now what I'm going to do is add some of this liquid that's being produced with this hydrogen sulphide. I'm not sure whether it's been produced enough, but it's clouded up, so it's obviously got some in there. And I'll add some. Now then, you can see what's happened. It's turned absolutely black. Turned absolutely black. Now that's an indication, and if I'd got some litmus paper and I could hold that in there, in fact I have got some litmus paper, and I'll just get some, it's turned that blue copper sulphate absolutely black. And you can see that really well. Now I haven't tried that experiment before, so I didn't know it was going to work. Now I'll just try if I can quickly go in here. Sorry about that, I keep breaking off, but I keep forgetting things. And get my litmus paper. Now I don't know what colour it said you had to use. Let's have a look what colours we got here. But we'll try with the blue one. Now I'll hold that inside there in the gas and see whether it does anything. There's very little reaction with that. So let's try a pink one. Let's try a pink one and see whether that does anything. Now I'm sure it says don't put it into the liquid. It doesn't actually tell you to try litmus paper, but I'll just see. I'll put some into the liquid, and that certainly turned that pink one black. But I didn't really want to put it into the liquid. But it has sort of turned that one black. So that may well be that the litmus paper does give us an indication. I don't know. It doesn't actually say to try litmus paper, but I thought I'd try it just for fun. But anyway, that hasn't been too successful. Now the next experiment it tells you about, it says make a dilute solution of cobalt chloride. Now I've made a solution there, and cobalt chloride is pink. This lovely pink liquid in here. And it says when you add some of this hydrogen sulphide to this, in theory, nothing should happen. Now it looks as if the theory could be wrong, because it has turned it a dark colour. Now that may not necessarily mean it's wrong. It may mean that there's no acid in there, because what it tells you, it said that it wouldn't change the colour at all. Now it has changed, it's gone dark. But it says that if you add ammonia